sure about the speakers, but I hope they will be well behaved later on. Also, you there in the last rows, feel free to push a little bit more. That would be nice as well. And also a warm welcome to our live stream online guests, because we are right now streaming from Munich. We have actually the room in here. I think you see it also through the other camera. And yeah, so feel free to write into the chat. I have a colleague also, Alex, who is maintaining the chat and also taking your questions. And we will include you interactively later on also via a question tool that you get some glimpse or at least some insights from our experiences here. Great. So let's start with Front-End Madness in Munich number 8 today. Yeah, I'm also very happy that Diva-e hosted us in their beautiful offices. Big thanks to the team and especially Sandra, who we were in contact with. Thanks a lot, and it's a pleasure to be here. It's really beautiful for those of you who are not here right now. It's like really green and there's some nice plants and all of this stuff. And you will see probably later on also on social media, some insight on it. Right. So I have some health and safety guidelines for you, as always. So please be aware of them, as we should be aware of it already for quite some time now, right? So please wear a mask if you're at least walking on the corridors, if you're going to the toilet, if you're taking the exit. For example, we printed all of the ways also actually also on the floor. Keep your distance, of course, with your hands, follow the instructions, and of course, just be mindful and respect each other. Great. So, oh, this is the link actually that we sent into the chat also for the question tool that we're using later. It's called Slido. And short notice for those of you who are joining online, we have found a solution on short term, on short notice. For those of you who are on Zoom right now, you could switch, you have the choice, no pressure, to switch on YouTube because the streaming quality with our awesome camera is better over there. And type your questions, as I just said, in the Slido app, so we can rank the questions later and include them into our audience here as well. So that was just a short intro for our online attendees. Great. So to sum it up for the agenda for tonight, we're a little bit late for the welcome, but we will keep up later on. We will have afterwards our first speaker, Benedikt, who will give us an insight about shortest time to interactive by extreme lazy loading. And afterwards, we will have some break, obviously, so you don't have to stay hungry the whole evening. We will have some food, some drinks also at the bar over there, and use this time for some networking. Afterwards, we have a second speaker, Yan, who's also with us tonight. I'm also really happy. And he will talk about how knowledge of JS engines will make you a better developer. So yeah, these two talks we're really looking forward to tonight. And afterwards, of course, we will have a post-event networking together. Right? If you want to get in contact, feel free to approach us later on. But I want to mention it as always, if you want to become a speaker, a community city lead, or sponsor, or have any questions, please write us an email. We're always happy to support you. Also, if you want to practice as a speaker, doing some speeches, or just want to share something with the community. Also, if you want to support us wherever you are right now, even if it's Munich, Berlin, Hamburg, you have like across Germany a lot of communities that you can support with, and yeah, also regarding the sponsor card, feel free to approach us. So to give you a short overview, some are already attending more events, so that's no new information, but for those of you who are the first time with us, just yeah, to spread the word, or to invite also friends or colleagues or whoever you want to invite to this gatherings or networking experiences to learn together. we have different communities across Germany. So there are like four like main topics, which is data madness, front-end madness, which we are right now, product madness, and also cloud madness or cloud native topics. So if you feel pulled to any other kind of event, feel free to join them as well, or tell your friends and invite them to join the experience. And also, as I mentioned, for Convicted Data Project, we have almost 3,000 members in these communities, and we're happy if you spread the word as well. Great. Now, saying something to the community host, Instaffo, I'll show you some words. Instaffo is a platform which is like stands out from normal recruitment processes, which provides you an easy and fast way to get directly in contact with job responsibles. So you can forget the classical process with application portfolio, like motivation letter, CV, cover letter, and so on. So you can just register in 2 minutes, get a match, and directly chat with job responsibles with no one in between. If you're interested in that, also feel free to process later. And I have also my colleague with me. He's over there. Alex, I'm looking for you. Who will tell you also more. He's from our front-end team, actually, who will tell you shortly something about our front-end team and some position that we're having right now. So the stage is yours, Alex.
Thank you. Thank you, Laura. So yeah, as Laura. As Laura just said, I am a front-end developer at Instaffo. My name is Alex, and I'm really happy to announce that we're searching for one more front-end developer to join our team. We are looking for someone that is motivated, passionate, that likes to learn and try different things out, and of course that writes good code. And the reason is we're growing right now, and to build a great product, we need great people. Why should you want to work at Instaffo and join us? Maybe I'm just a little bit biased because I work there, but I think it's great. It's a great company. We have an amazing team, great people. You can learn a lot from everyone. But not only that, we have a great dev team. We have 3 backend developers, 3 front-end developers, and together with the product owner and the designer, we work together to make amazing features. Not only that, but we also have agile process. We use sprint, and what I really like about the company is that we have a lot of control of the process, of the way we work. And if there's something which you don't like, you can change things in the process, and of course that makes the work much better. And as I said, the company is working right now, so there's always new challenges coming up, and that of course keeps the job very interesting, very exciting. And also, I think we have a great tech stack. We don't have any old technologies or old legacy code that we have to support. And we also have a lot of freedom. So if you want to introduce new technologies, we actually encourage that because we want to build the best product that we can. And there is always that option. So if you love to learn, if you want to go to work at a great company, create a great product, then I would encourage you to scan that QR code. It will take you to a job detail page where you can find all the information. You can apply there directly. And of course, if you have any questions, you can just email me at alexander@instaffo.com, or for the people that are here, you can of course talk to me later. So, our sponsor and event host Diva-e is going to say a few words.
Thanks, Alex.
Great.
Let me see. We need to switch here sometimes. made. So thank you that you are here today. It's a blast to have you all here. It's so nice to see everybody here in this room. It was a long time that COVID separated us, and it has to be, but it's now great that we are here and already saw some interactions here, and this is really something that is great and what we love at Diva-e, and it's nice that we have you all here. So in this kind of matter, this is what I feel right now when I'm standing here, and this is just possible because of you. So give you a warm welcome and a very nice applause to yourself that you're here. Woo! Yeah, and all this wouldn't be possible without the team of Instaffo. So definitely a big applause to them. Look at the equipment, look at the nice people, and the great presentation of the front-end team. So if you're interested in Instaffo, talk to them later. They're really cool guys and cool girls. So join them. It's one person who can join them. All the other front-end developers can join. So yeah, I guess interaction got a little bit rusty over the last year. So I want to hear, why are you here today? Is it because of the free food? Hands up. Hands up. Okay, we had some free food. Oh, somebody raised the beer, but this is the next question. Are you here for the beer? Okay, we have wine too. But I guess we can now all raise our hands because we're here for the two developers who really present us a nice talk today. Woo! Hands up! Yes! Here we go. Okay, yeah, and coming together, this is what we love at Diva-e. We want to be together, and this is why we had lunch this time together, or this today, and it looked like this. So it was a pleasure to eat this, and yeah, this is something we really want to have more and more, and having a good time together. And yeah, but this is just a side note basically. What really matters at Diva-e is really the heartbeat for each employee. It's really I don't want to say we love each other, but it's really a deep connection between everybody, and we feel each other. And this basically is through the daily work, we want to give everybody a vision, so that they have a personal future, and we want to develop this future together. And yeah, for sure, you definitely always should have the possibility to grow each day. And for example, we had the Hack Week in 2018. We met us at the Bavaria Film Studios, Studio 9, where they do film movies for ProSieben. And we met everybody from Diva-e. It was around 600 people, and we built really crazy shit. It was we used technologies beyond the Tellerrand, and we did cool stuff. Or other people went out for a week working at Pixel or something. They had the best view ever. They could see a better view to the Zugspitze than we have here. So this is just a bit of what we want to offer our colleagues, our employees, to get together, to get the passion for the team. And yeah, I mean, this is something our clients also then notice, that we want to work with a team, as a team, and this motivates us each day. And so what we deliver to our clients is basically everything in the digital value chain. So we start with the strategy, the digital strategy, go further to the UX, to the UI, and the front and back end, CMS. You know all that stuff. We do that for them. For example, at thebayern.com, you see some logos in the tree hanging there. That we can talk about this later and all the good stuff. I guess I forgot some slides. Yeah, it's about team spirit. I told you already. And what I want to give you as a takeaway is at Diva-e, it's all about the heartbeat of each employee. So thanks everybody to be here, and now I wish you a good time with our two speakers. Finish.
Thank you, Marcy.
And welcome to our audience from me as well. So I'm here today to talk about the fastest time to interactive by extreme lazy loading and 20% less ad revenue Google says they would make if the page load time went up by just half a second. I'm Benedikt Böhm, I'm your speaker today, and first let me tell you some short points about me. So breaking this down in 4 points, I was born 1991 in Munich, and now big jump, I got hired by Diva-e 2016, and here I'm still working as a senior software developer and front-end team lead right now. I did my Master of Science in Computer Science 1 year later in 2017, and today I'm here to tell you how Google can keep their page load times low. And of course, not only Google, but all other companies such as yours as well. So I'm going to split up this talk in 3 parts. First is some hard facts about time to interactive. So definition, what is it, how do we measure it, and what's the current state of the web in this regard. Second, I'm going to talk about ways to achieve faster time to interactive. And third, I'm going to show you a practical demonstration. So, time to interactive, what is it? We can say time to interactive is the amount of time it takes for the page to become completely interactive. And it's one of 6 metrics measured in Lighthouse. But since that is still kind of vague, what does that mean? It means we have a complete render of the page, at least for the part we can see. It means the event handlers are registered, and it means the page responds to user input in a really small time of 50 milliseconds. Why is that important? There are several factors. First is UX. So if a user tries to interact with a web page and the web page doesn't respond, the user gets frustrated and he or she might start to rage click and finally leave the page, which isn't what we want, of course. And who never experienced that by himself or herself, just take out your phones and try to open the page from the RKI, Germany's official incidents website. So it's corona.rki.de. Just do it right now. I continue because it might take some time. Next is SEO. So while time to interactive isn't part of the Google Core Web Vitals, the total blocking time is, and those are closely related. And as we will see later on, our approach helps to reduce total blocking time as well. So we have an impact on SEO, and that's something we should strive for. Why? I mentioned it earlier in the example of Google, but that's not the only example, of course. Amazon says they would lose about 1% of the revenue for each 100 milliseconds the page load time decreased. So there is quite a big factor in making money in page load times, and that's why we should have a look on it. But first, how can we measure time to interactive? There are several different ways. We can use the Chrome DevTools in the Lighthouse tab. We can go to the PageSpeed Insights website. We can use an extension for Chrome, which is Lighthouse as well, or we can just use Lighthouse in the Node CLI. So different options according to the situation and your personal preferences. I will use the Chrome DevTools today, and we will see this later on. So, what's the current state of the web? I had a look on different websites, and as we can see, some websites achieve quite good results for desktop users. For mobile users, it's really hard, it seems. So the only ones I found with a good or rather mediocre result is Amazon. So it seems like a whole industry has a problem of getting good time to interactive on mobile devices. So that was part one, and now we'll have a look on how we can achieve faster time to interactive. And I see there's a question in the audience. We have some time for questions later on, so if it's okay, I would just put it back. So ways to improve time to interactive. I'm sure some of them you have used yourself already, but probably not all of them. So there is minification and compression of code. You can use caching, you can preload critical assets, you can split up your code, you can minimize your images, and you can remove that code and so on. What we will concentrate on today is lazy loading the parts of code you don't need right at the beginning. So how does that currently in modern frameworks work, such as React or Vue? Let's just assume we have some server-side rendering, and of course our goal is to interact with the website. So what's necessary for that? Of course, the event handlers have to be registered, and for that, the page has to be rendered. And because rendering in current frameworks depends on data, a state update is necessary. And to be able to do all that in the beginning, there's a huge load of data necessary, which all increases time to interactive. And if you have a look at an example, then here's the is an example page from Amazon. It's just some random product page. And if we have a look on that, we see different event handlers or different elements we can interact with. So there are some pictures we can hover over and which will show us another view. We can toggle some options. We have several menus on top. We have a search. We have even more menus. We have some buttons. And if we would scroll down on this page, there are several sliders, for example, and still more elements to interact with. So you might ask how many event handlers are on this page. And I personally was very astonished when I realized how much there are. So for this page, there are over 100 event handlers, which is quite a lot. And all of these get loaded in the beginning, so that takes time. How can we improve on that? If we go and take an approach with a DOM-centric and extreme lazy loading, then we can achieve better times. Why is that? We can skip almost completely the render and update state phase because we have our data in the DOM, and we register event handlers right in the beginning. And their only job is to say, hey, where can I find the information I need? Where can I find the code I need to execute? And this is all we need to download in the beginning. And everything else gets downloaded later. So time to interactive shrinks quite severely. So the philosophy behind this is nothing is faster than doing nothing. Yeah. So delay as much as possible, and do that by lazy loading and using async primitives. And secondly, aim for 100% of loaded code to be executed. Otherwise, if it doesn't get executed right away, download it later. And therefore, use a fine-grained handling to be able to do that. So now I'll show you a demonstration. And I made a short, small app for that, and we'll just jump into it. So this is the app. It consists of 3 parts. First of which is a to-do list. So I can add some tasks like give a good talk today. Woo. Yeah, and of course I can say, hey, I did some of these already, so mark them as completed. And if it gets too chaotic, just filter them, or just show me what I did already. And of course, if I made a mistake, I can also delete an item completely. That's the first part. Second part, we have a graph on the items completed in September. So, to be honest, I used the library for that, and that's just because I'm lazy. Thirdly, there's just some plain text as general information in the third tab. So let's have a look on the code. And here we want to go to the index HTML. And this is one of the clickable elements you see right here. And what you might notice, and what's worth noting, is that we have several data attributes on this element. So there's a data type click, and there's a data path in toggle.js. What's this for? This is exactly for registering our event handlers. So the information we need is already in the code completely. It's in the DOM when it gets loaded, so we don't have to wait for anything. What happens with that information? Let's have a look on that. We have an add event listener function, which goes over all elements with the dataset type and just attach the event handler. So for example, if we want to toggle it to do, then here's the onToggle to do, which gets imported in the beginning. And the problem with that is that we import it, so it gets loaded in the beginning and it gets just executed. So having a look on the web page, especially on the dev tools, shows us in the network panel when we do a reload, we have a size of 1.4 megabyte, which gets loaded right in the beginning. And of course, that's mostly due to the library for the graph rendering, which we don't see now and which we don't need now. So how can we improve on that? That's the big question. And the answer is quite simple. Because what we can do is we don't want the tab toggle to be loaded in the beginning. We don't need it. So kill it here and kill it there. And instead, we lazy load the file where it's in dynamically. And afterwards, just do the default handler of this module, which is exactly the same function as before, but it gets loaded dynamically, so we don't need it in the beginning. And let's see how that improves our file size, and it shrinks from 1.4 megabytes to 173 kilobytes. So considerably less than before. Going back once more to the original state, let's have a look on Lighthouse, as I mentioned before. And since we want to do it properly, tackling the problem by the root, so to say, we do it for mobile. So let's generate a report. Takes some time, so we just wait a short time and do it once more, because in the beginning the total blocking time doesn't get recorded correctly sometimes. Yeah, now we see it, and now we see we have a very high time to the active of 10.8 seconds. So over 10 seconds here, we have a total blocking time of almost 3 seconds. A good value for total blocking time would be below 200 milliseconds. Good time to interactive on mobile would be below 3.8 seconds. So we're quite a bit away from that. And as you all can see directly, our performance score is somewhere mediocre with 56. That's not what we want. So doing it dynamically once more, let us have a comparison by just reloading. So load files here and do the audit again, waiting for the result, and we directly see the difference. Yeah, total blocking time, we can do it again as before, sure. So it's still on 0 because we don't have any total blocking time anymore. That's because the total blocking time in this example was again in the graph tab of the app. And as you can also see, our time to interactive improved to 0.9 to 2.9 seconds, and our overall performance increased to 91. That looks good, but it isn't where we want to end. So what can we do more? Well, of course, we can do the same thing, not only for clicking on a tab, but for each event we have on our page. So let's do that shortly. So get rid of all the static imports and just import them dynamically. There we are. Save and reload the page. And we run the audit. So again, takes some time, of course. And now we see our time to interactive decreased again to 1.4 seconds, and our performance is at 100, so as high as it's possible. That's really cool, isn't it? I'm still not satisfied by that. Why not? Because right now, when I click on the general information, nothing happens for some time. Why is that? That's because in this time, I have the tab toggle and the library for the graph gets loaded. So I can take this approach one step further, and that was one, sorry. Go into the tab toggle. For the tab. No. Okay. Just give me a second. Make this large again. So, and here we'll do the same. So don't import our library statically. Here. So again, we load our library, it's called View3, dynamically. and see what happens. So right now, do a reload, go to the general information tab, and there it is. And of course, when we want to load the graph, it takes the time because there we need the library. So that's the result we achieved. We decreased our initial JavaScript file size from 1.4 megabytes to 21 kilobytes. We speeded up our time to interactive from over 10 seconds to 1.4 seconds. We completely got rid of our total blocking time of 2.8 seconds. So that's 0 right now. Our performance increased from about 57 to 100, and we don't have any unnecessary load times anymore. That's what's possible with this approach I showed you. To sum it up, I showed you the importance of time to interactive, so UX, SEO, and monetization. We saw that the state of the web in this regard is problematic for most companies, and improvements are in dire need. We saw the problem in current frameworks, which have a huge data load in the beginning, because they focus more on the runtime than the time to interactive. And I showed you an extreme lazy loading approach with the DOM-centric data handling, and with the philosophy that nothing is faster than doing nothing, and where we strive for 100% of code being executed. And we saw that we can achieve improvements on the initial JavaScript file size, on the time to interactive, on the total blocking time, on the performance score, and on unnecessary load times. Thanks for your attention, and now I'll answer your questions.
Thank you so much, Benedikt. I would suggest that we give them a microphone so also the online attendees can hear them. So sure. I will just start with you because you're accepted.
I showed you a single page application, so there it works definitely. For other websites, you probably would have to do this for each site on its own. So they can vary in the time to interactive. The start page might take another time than some product page, for example. So you would have to look at each page separately, but should work there quite well as well.
Thank you. So who's next? I haven't seen it. Or is anyone? Do we have online questions? So if you're online also attending, feel free to post your questions in Slido. Alex is checking them. If there are any questions from someone else, feel free to give a hands up.
Then I go. I have one question.
Great.
So I can imagine myself like reaching one very good score once, and then I know we add more features or whatever, and then or we add a new library, or I know we don't notice, and then the score goes down and we don't notice. So are there any practices that you have that so that you can continuously add features, improve the website or the application, and still maintain that score?
Well, it's mostly about discipline, I would say. If you set it up once, as I did, with the data attributes in the code, so that you know where event handlers get registered. You don't have to do much for registering the event handlers yourself. You just have to write them in the right file and to put the code in a separate file. So it's quite easy to achieve and it scales up. So definitely possible.
Yeah, I was wondering more like, do you have any practices like that you can include in the CI pipelines so that you can always get alerted if it drops or something?
Right.
Like that.
So as I showed on some slide, let me just go back. We have different ways of measuring time to interactive. So, for example, from the node CLI, so it would be possible to include that in GitLab CI, for example, and to make some tests for a score we want to achieve there. So it would definitely be possible.
Nice. Thank you.
You're welcome.
Awesome. Okay, we have someone over there.
Hello, thank you for the nice presentation. My name is Max, by the way. I wonder, so the approach you showed us, it of course brings a good DPI time, but the downside would be that every click for every handler, something will load, and sometimes the connection might be bad, especially on mobile devices, and there is no reaction, there is no interaction. The user doesn't know what's happening. And of course, it's a general problem for some loading states, indication, and so on. I wonder if you have like a generic approach, because putting everywhere like a loading state, pulling or flags or something is not nice.
Yep.
Just
You're right about that. So that is a downside of this approach. We have load times when interacting. If you break it down, they get quite short in many cases. Not always, of course, but in many cases, the user won't even notice it, I guess. If you have a bad connection to this moment, and if you have to load a library right then, for example, then it will take some time. That's definitely true. And I didn't show it because it was just a demo. But of course, there should be some loading indication for that time there. The upside, on the other hand, is that this loading would otherwise occur on the page load itself. So you don't spend more time, and you only occur this problem when you really need the code.
thanks. I mean, I'm not arguing whether it's good or bad. It's just I wonder if you have a generic approach for these loading states where it might make sense.
Yeah, you could probably just add them when you register the event handlers. So say like show a loading indicator, and when the page is loaded in the promise handling, I can show this once more. So we see we get a promise here, and the promise executes. So we could just say, okay, each time we register, we do something like show loading indicator, something like that. And down here, hide loading indicator. And then it would automatically come up each time a event handler is registered for the first time.
Thank you.
Welcome.
Thank you. So, yeah, Alex, do you want to hand over the microphone over there?
Yeah, sure. But first,
Or
we
I
have one
also-
online question.
Yeah, then I just use this time to bring the microphone into the microphone.
Okay. So we don't have his name because he asked someone else. But is there a reason why the mobile measurements are so harsh?
I don't think they're so harsh. So as I said, Google says 3.8 seconds is for a green result, for good result. And compared to desktop, I think on desktop it's 2.8 seconds, so you have a full second more. And where comes this from is on achieved results. So as far as I know, Google takes the results over the whole web, and I think the best, about 10%, are what they declare as a green value, as a good value. And so there are some who already achieve this on mobile apparently, but I think it's quite hard, especially for bigger companies which use a more complex code layout on the page.
Yeah, thank you. So do we want to go on?
My question is very similar. Do you think it makes sense to make a distinguish between mobile devices and desktop devices? Because in mobile often you can't check to-do items without loading in.
Yeah, I would say this is definitely something you should consider nevertheless. But I think sometimes it's necessary to load things, especially when you go to a website the first time. You don't have some cache, for example, you will have to load. And then it still is useful to get this time to interactive then as low as possible.
So how is it with the time? We still have 2 questions online.
Yeah, I think it's fine.
Yeah, great.
Before we start, yeah.
So Ben asks, is it only external dependencies that we should be looking for, or are there any other things that we should consider while lazy loading?
I think external dependencies might make the most impact, but as I showed you, they're not. It's not enough to just get rid of them or to lazy load just them for really good scores. So yes, you can eliminate some of the problem when considering them, but not all of that. So that's why I showed you lazy loading all of the event handlers makes sense in my opinion.
Thank you. Okay, so we have one more online question. So what is the best way to improve time to interaction in a Create React app, where there are a lot of vendor libraries and the bundle can be very huge? How can we use this approach to extreme lazy loading?
Very good question indeed, because React struggles with lazy loading as it is. I think they're right now looking into that, and I think there are some lazy loading approaches for React already out there. But to be honest, I can't answer this question right now. So that's why I said current frameworks are struggling with time to interactive. It's just part of the problem.
Nice, thank you.
Oh, we have one more here.
Nice.
Maybe a follow-up question on that. How would you do it with vanilla JS if you don't have any application framework?
Yeah, for vanilla.js, it's basically what I showed you. So key aspect for me is dynamically importing our needed JavaScript files and of course splitting our code into several files so we can keep the loaded file size as low as possible for each interaction.
Okay, we have one more.
What do you think about Svelte.js? I think it will be perfect for best time to interact.
I'm a huge fan of Svelte, so try it out. I didn't try it in Svelte, but might be a good follow-up.
Yeah, wanna try it.
Awesome. Do we have any question left here in the room or even online? I would say
No, online.
we have
There are no more questions.
Okay, nice. So I think we can also go for our break. Just to give you 1 or 2 hints. We have awesome, delicious finger food over there. Please respect that you just take a short blow while you're picking your food, and you can pick the drinks for sure. They're like just like as you probably have already seen the beer or like a Coke or some soft drinks, and just respect that your brotherhood. And, I would say just that you have it in mind, and you have now, yeah, almost a quarter to 8. At 8:15, we will continue with Yan, who recently asked the question, with the second talk. So please keep it in mind later on, and happy break for everyone.
And we end with a great round of applause for our speaker.
Thank you. Thank you.
Ja. Ja, jetzt nicht alles. Ja, und halt irgendwie die meisten Fragen kamen so ungefähr aus der Mitte, aber ich stand dahinter nicht von ganz links.
Möchtest testen? Oh.
Working hard later on as well, so don't worry about that. As we already decided, we won't let you go home hungry. And I have pizzas ordered. Did you hear the sign? Really cool. Nice. So I have just, one short thing before I announce Jan. I just need, wants your attention. So something came up during during the break, some short bet with my own marketing colleague, and I wanted to get you into the loop. I see some questions in your faces already, especially you. I will tell you. So my marketing colleague and I, we have a bet. As we introduced in Instaffo earlier, we're having a short UX research, which just takes 2 minutes of time. I don't want to annoy you with this right now, so I don't let you do this right now. But we will send emails out after the event. And I have the bet that I will get 30, how do you say? In German, it's Ergebnisse. 30 answers. Yeah, answers faster than him until Monday. So please keep that in mind when you go home and you receive an email to support me personally, because I will put my link into that email and he has another link. So just keep that in mind. If you get that to support me personally, I'd be really happy. So I just, I know that you're watching right now. So just to introduce you into that bet. I have with my marketing colleague about that short UX research. Great. So now it's your time, Jan. Finally, we're really happy and thrilled for your talk. And Jan will tell us, I wanted to introduce him. He's a senior front-end mobile developer at Sincere. And he will tell us right now how knowledge of JS engines will make you a better developer. So please welcome Jan again with a short applause.
So, you know that engines, they have lots of secrets. JavaScript engines. Yeah. Yeah. So my talk will be about JS engines and how to be a good developer knowing their secrets. Let's take a look at mainstream engines. Maybe all of you know V8, SpiderMonkey, JavaScript Core. Yeah, maybe some of you were working with Internet Explorer with their engine and with the Opera engine some years ago when they were popular. So let's take a look at V8. It's like the most mainstream engine. It's been used in somewhere around 50%, 55, even to 60% of devices all over the world. And yeah, previously there were lots of talks about try-catch, non-optimizing problems in V8. Modern V8 pipeline, modern V8 compilers, they can optimize try and catch. So it has full modern ECMAScript support, by the way, and it's increasing. Yeah, what makes it fast? It compiles to platform-specific meshing code. Actually, it's around 10 platforms nowadays. And talking about time to interact, it has two-tier compilers. The first one is baseline compiler called Sparkplug, and the second one is high-impact optimizing Turbofan. So to have shorting the shortest time to interactive, it will compile with a non-optimizing compiler first. That like goes from Ignition. Ignition is like compiler from abstract syntax tree to bytecode, and it creates like intermediate representation. Yeah, also it supports WebAssembly, and it has, of course, obviously garbage collector. Yeah, in the future, if I'm not mistaken, the V8 team, actually it's from MUNICH, it's going to introduce low impact compiler Turbofan. Yeah. So the pipeline of V8 looks something like this. Now it's oversimplified. We have source code. It goes to parser. Parse creates abstract syntax tree that is consumed by Ignition. Then it produces bytecode. Then to have the shortest time to interact, it goes to non-optimizing compiler Sparkplug. It gives profiling feedback to Turbofan, actually, and in the runtime of Sparkplug, it creates optimized meshing code based on what we got from running code. Hotspot, it's function that is simply saying hot. It's some function invoked too many times, and then engine understands that it needs to optimize it. So let's take a look at Spider Monkey from Firefox. Yeah, it has modern ECMAScript support, compiles to machine code, Trace Monkey since 2009. It has baseline interpreter and optimizing compiler Iron Monkey, and during my preparation it changed its name to Warp Monkey. So yeah, also it has garbage collector and WebAssembly support. So they're working on it. I think every compiler teams are working on WebAssembly support now. It's very popular. So a little bit more simple. We go to interpreter to produce bytecode. Then bytecode is considered by baseline. Some baseline consists of C++ compiler. And then, if I'm not mistaken, it's baseline just in time and baseline interpreter. Then it goes to create somewhat optimized code. It's profiling for Iron Monkey or Warp Monkey, and then it goes to optimized code. Yeah. And we will talk about the optimization a little bit more. Yeah, I think lots of you have Apple devices. So JavaScript core is a compilation engine from like supported back by Apple, and all iOS browsers, they are working on JavaScript 4. Also, Apple Safari uses it, and yeah, also supports modern ES, but it's not using machine code. It's virtual machine. Yeah, and it has quite crazy for-type compilation with the startup interpreter, baseline just-in-time, low latency, like low latency optimizing just-in-time compiler TFG, and high throughput optimizing compiler FTL. Yeah, know the names, FTL, warp. Yes, and so these compilers, they're working in a different states of code functions. So for example, if function is invoked for 100 times, it will go to TFG, and if it's invoked 1000 times, it will go to FTL, faster than that. Yeah, also it has garbage collection support and the bus support. Yeah, just overview of compilers. Yeah, containers. So we will have different results, different code. And there is one thing called on-stack replacement. If the engine understands that function is getting hotter, it will on-stack replace to next level. Or if engine will understand that the optimizer is not working properly, or there is a optimization, it will on-stack replace that. Probably. Maybe some of you are using React Native, and the HMS is engine of React Native. It's quite new, supported by Facebook. Yeah, and also there is a JavaScript. It's super lightweight engine used for Internet of Things, like up to the size of this engine is somewhere around 100 kilobytes. Yeah, and there are lots of other engines. Some of them are supported, some of them are not. So then, yeah, for example, Nashorn and Rhino, it's they are based in Java. So bright ones run everywhere. Yes. And what's your favorite browser? Who's using Chrome? And who's on Firefox? And who is using Safari?
Yeah.
So, yeah, you know, now you understand what's behind these bright names. What is a compiler? A little bit of theory. Compiler is a computer program that transforms the code from a high-level programming language to low-level machine instructions. It's very general saying, because there are types of compilers that can actually transpile the code from high-level programming language to a high-level programming language. For example, TSC, TypeScript, or CoffeeScript, or yeah, lots of them. Yeah, the compiler versus interpreter. Compiler prepares the code for execution, and the interpreter it like goes through the code line by line and executes it. Generally, yeah, there are also all kinds of compiler called just-in-time. So they have a when you're running them, they have a feeling that you will have a feeling that you're running interpreter. So browsers they're using just-in-time compiler. Yeah. It's a little bit of JavaScript theory, even compiler theory. We have two stages, two steps: analysis and syntax. Analysis step, it's saying that we are getting code. We need to prepare it to the like machine code generation. And machine code generation is synthesis. So analysis creates some intermediate representation. In our case, it's abstract syntax tree. And synthesis ends with that result program, something we can run in our machine. Yeah, let's take a look at the most used engines analysis step. It's often called parser. The first part called scanner takes characters from the source code and groups them into lexemes which correspond to tokens. Also, it removes comments, adds semicolons, removes white spaces. So unify your code to avoid this, to not make the engine do it for you. The syntax analyzer, also called parser, it constructs the abstract syntax tree. And also there is one third step, semantic analyzer. It like verifies this abstract syntax tree. Let's take a look at the pipeline. Blink, it's a browser engine of Chrome. Yeah, and it's a string of characters. Prepares PDF 16 code units, then it goes to scanner. Scanner prepares token. The preparser, it's like lightweight parser that understands what code do we need to parse for a feature called lazy parsing. It's quite old. It's maybe more than 10 years. It's used in browser engines. Yes, very necessary part to shorten time to interactive from previous talk. Yeah, then it goes to parser. It goes, in our case, to ignition. Ignition, it's compiler to bytecode. Bytecode is intermediate representation for optimizing and non-optimizing compiler. Then it goes to compilers, then that will produce meshing code. Yeah. As I mentioned before, lazy parsing mentions only function necessary for application startup. Preparser can skip unnecessary for startup functions. And one really interesting thing, IAP, it's intermediately invoked function expressions. If you check your minified or occupied code, you will see that lots of modules, functions, they are wrapped to parentheses. They're like intermediately invoked. And browsers, they know which of them will be invoked, which of them are necessary for startup, and which of them are not. So we call possibly invoked function expressions, this optimization. Yeah, parser can take up to 20% of compilation time. Yeah, and the most necessary thing is to create even other parsers. They use a simple lookup table for single ASCII character strings. So we have basic, really basic reduce, and the source code, the abstract syntax tree generated by our parser will look like this. With this token, with this. Yeah, so the function is without name, so generating back of the function empty. Here. How to optimize? Unify your code. Because V8 scanner works with single characters and character identifiers. It's very necessary. And before loading of code models, then you don't need to the application startup yet to make time to interactive as low as possible from previous talk. Check your node models, remove all unnecessary dependencies. Yeah, we have lots of garbage there, and they're using like huge, insanely huge libraries in our code. So take a look at smaller variants. For example, lots of people are using Moment.js, and there are more lightweight solutions for that. Yeah, also I wanna mention pre-shaking. Pre-shaking, it's necessary thing. It's, for example, it works in Webpack, and there are lots of tools for better pre-shaking. And use like the tools for find bottlenecks. Also, you can use D8. D8 is developer shell of V8 for finding bottlenecks. And of course, transfer less. I found this tip funny. Transfer less. Yes, you need to know what your Babel TypeScript compiler is doing, and avoid too much null checking or syntax sugar whether it isn't needed. Yeah, it can create some extra code. Just take a look at your generated code. And also, I want to mention that modern browser they supports more modern targets than default pipeline, default TypeScript configuration have. So you can, for example, use ECMAScript 2017 or 2018 target, and you will have less generated code there, but you need to test it. Yeah, let's talk about the second step. Code synthesis. Intermediate code generator, code optimizer, and target code generator. Target code is code, mesh code. Yeah, intermediate generator generates an intermediate code that can be translated into the machine code. So non-optimizing to optimizing compilers that are working with this intermediate representation. So they don't need to work with the abstract syntax tree. So it's more effective. Yeah, optimizer, if function is called, or if code is, it can optimize code, it will make it faster and more effective. And then code generator will generate your meshing specifications. So intermediate code generation. V8 has ignition. It's a fast low-level register-based interpreter. Experiment it has actually it's C++ interpreter, but it has like this baseline compilation pipeline. So I can say that C++ interpreter it's a kind of intermediate code generator. And GSC JavaScript core has low-level interpreter, but it's something between code generator and the non-optimizing compiler. So it can also generate the source code, the machine code. So ignition, it's a good example. It uses turbofan slow-level macro assembly instructions. Turbofan it's optimizing compiler, and also uses spark plugs instructions. And these compilers like sparkplug and turbofan, they will compile these instructions to machine code. Yeah, so we are getting abstract syntax tree, then it goes to bytecode generator, register optimizer. It does some basic optimizations in the very beginning. Also, dead code and elimination. So if you have something that won't work, it will remove it. And then you will get your internal representation in the end. This step is very necessary. It's very necessary for time to interact. because V8 got Spark plug 4 or 5 months ago, and the startup time was reduced by 5 to 15% in some cases. Yes, and all of these modern engines, they have this step now. Low impact optimizing compile. So some functions run for not enough time to make an aggressive compiler profitable, but long enough then that some intermediate compiler designs can provide speedups. So from all of them, only JavaScript 4 has this weird low compact optimizing compiler. So we can jump between the power of compilation. And also V8 has turboprop, but it's turned off. It's like simplified turboprop. Let's talk about diamond calculations. This part is used everywhere. You know that we have numbers in JavaScript, but some numbers can be represented as small integer or int 31 or int 32. Yes. So if we are using statement with the, for example, array adding to array with the int 32, we can go past that and add it and go forward. If it's not int 32, if it's heap object, string, whatever, it will go here. We will solve that. So this is kind of optimization to handle fast things or generic things. And also the most powerful thing is V8 has turbofan. It's optimizing compiler. V8 has turbofan. SpiderMonkey has Iron Monkey or Warp Monkey, and JavaScript 4 has faster than Lighthouse. It has two representations, bit3 and air. Bit3 does code optimization, air works more with assembly, if I'm not mistaken. And yeah, let's take a look at turbofan. Yeah, as you can see, this pipeline is quite big. We're getting bytecode profiling feedback from SparkFact, for example, and then we will go through lots of different optimizations. This everything is simplified here, oversimplified, and then we will have our machine specific code in the end. So let's go and talk about optimizations and bailouts. Second name of the optimization. Compiler optimizations. It's like inlining. It's called mother of all optimizations. It's about to avoid too much function calls. By the way, optimizers work better with the small functions. Let me show you. Here. For example, we have a function that spares. Sorry. We have a function square here that is invoked in some function that makes square from 0 to and it's involved 10,000 times. What the optimizer will do optimization of this function because this square is too hot in this method. Fx is too hot. And it will generate something like this. So you can see it's replaced the function with the its return. And the optimizer, like the information from optimizer will look like this. So considering this function for inlining with the sum feedback, and it will say that it's a candidate for inlining, and then it will inline this function there. It really speed up everything. So we won't have, then we won't have function that will be really hot. Yeah, as I mentioned before, unexpected placement is a technique for dynamically transferring execution between different versions of a function at runtime. So our engine can do the optimization to different layers of optimizer with this on-spec replacement, or it can do optimization with it. To go to the next slide. Yeah, let me say you something about this small integer. Small integer, it's a 31-bit or 32-bit integer used by engine that is like really fast to think, and there are lots of native methods working with this methods with this small integer, and which makes it natively fast. As I said before, it's used, for example, in diamond speculation. Yeah, as I said before, one really known optimization is elimination of dead code, and there are lots of other optimizations. I will give you some interesting links later. Yeah, also this topic, like data access optimization, was really popular in other JavaScript talks. Maybe you heard about hidden classes, maps, structures, shapes, inline caches, and array access optimization. This topic was really popular. Hidden classes, it's a non-brand name, it's like more scientific name. They called maps and V8 and the structures and shapes in other languages. In JavaScript programs, it's usual to have multiple objects with the same keys. So engine will create hidden class for each object of the same type, and it will attach bracket shape, and that slightly reduces property access time. Yeah, mainly for inline caching. So if we will add property to existing object, the old hidden class switches to the new one with this property. So it takes some time and some power. Since there are two different classes, the engine can have fast access to its properties because it can do inline caching. Yes. And if we will create empty object here, we will have shape empty. Then if we will add x, that will create a new shape with x, and then we will add 6 it will create next shape. So we will have 3 different shapes here. I don't know what I'm saying. Line cache. It's a thing that is used after in classes. JavaScript engines use inline caches to memorize information on where to find properties and objects, reduce the number of expensive lookups. Each engine caches the type of object that we pass as a parameter in method calls. Yes. And it uses this information to assign the type of object that you will give as a parameter in the future. If it's true, it will skip the access to real object and return cached value. It's really increases speed. So we have function get x from some object, and x returns, yeah, we are passing this object as an argument here, so it will look up, like it can look up to the x, and then it can use cached information to make a faster lookup. Yeah, we were talking about optimizations, and now let's talk about that. If like dynamic check of optimization first, the optimizer builds the code. It discards the optimized code, builds the interpreter frame for optimized stack, switches to the lower impact compiler, for example. And one of the examples of allow popular invade, it's not a small integer. If you are using, if you will add the string to array of small integer, it will optimize it with a bailout named not a small integer. Actually, there are lots of them. I will give you a file with them. And my advice to you: try to define all properties in the object's constructor, like immediately, not to add them to create hidden class in the very beginning. If you are dynamically adding new properties to the objects, always instantiate them in the same order, so that hidden class may be shared among this object. Yeah. And try not to add or delete object properties in the runtime, but actually it's not actual anymore, because modern engines can do delete optimizations. That's some new information. Yeah, and always construct the same type of object. So if you have object with integer and the next object with string, you will have another hidden class. And also function arguments should have the same type, because they are also using hidden classes. Yeah, I've uncovered garbage collection from tools, profiling and performance benchmarking tests in my talk. And also I've uncovered WebAssembly. But my advice to you, like homework, is to try to compile Create on your local machine, and try to play with V8, the developer shell, this engine. Last question for you. Why do you think all iOS browsers are using JavaScript code? Who knows?
Korean company that forbids other JavaScript engines.
Maybe, but
If you check the
They are saying they don't want to kill other JavaScript engines. Yeah, they killed Flash. They killed other companies like Nokia, or they killed other operating systems except Android. But they say that they are using JavaScript core to reduce the size of the applications. They don't want to store V8 in other applications. Yeah, but I think they want to kill that part. Yeah. So if you want to look, if you want to take a look at some interesting links, you can go here. Yeah, I have one Mac, and it was a little bit hard to install the D8 and V8 on it. So I have the way of installing the V8 on Mac. Okay. Guys, do you have questions?
Yeah. Microphone?
So yeah, I heard that the pizza is already there, and some people seem hungry, and so yeah, we can make a few questions. Go ahead.
Combine this.
I think yes. Okay.
Okay, thanks. Thanks for the interesting presentation. I still kind of wonder why I would need to follow these suggestions. And then I mean, what I mean is that let's imagine I am following the suggestions. I know write inline things instead of extracting functions, defining properties, end up or like okay, TypeScript is different version. What it gives me, what are the numbers? How faster my code runs? How much faster it runs in the browser? Should I really bother that, or should I don't care about and leave it out to the compiler to optimize it?
I think in some cases, like writing crypto libraries, it's necessary. And when you're writing functions that are being invoked for 100 or 1,000 times, yeah, it will be necessary. But in general cases, you can avoid this. Some of these recommendations. Yeah, it's just for critical hot spots. And also inlining, it's not a recommendation. Inlining is what engine does inside.
So let's say I'm an average developer writing some React websites with many images and so on. Should I care about these kinds of optimization?
I think you need to follow Martin Fowler's advice not to do pre-optimizations because they can kill the product. But if you have really hot spots, you need to take a look.
Thanks.
All right. So because of time constraints, I would say one or two more questions. Okay, I think people are waiting for a pizza, of course. And of course, if you have any other questions afterwards, you can talk to Yan directly. But now, round of applause for Yan.
Thank you. Thank you.
Yeah, thanks a lot, Jan. And let's have the second food round, as Alex just said. And just feel free to approach Jan with further questions. And yeah, happy that you joined us tonight. Have a nice evening.
Yeah.